Math Analysis. Last lesson of chapter 1 here, chapter 1, lesson 6 notes, and we are going to graph inverses of functions. This one is actually kind of fun, and I'm going to get out some colors to do my graphs in. Oh, that's right. Let's get out all the big pens. What's the colors here? I'll pick as I go. You don't want to leave purple out, even though it's a trash color. You can fight me on that all you want later. All right. So let's see. Analyzing inverses of functions. Ooh, okay. This is a good time. This is kind of fun. Just pull my emulator up so I can pull up some stuff when I want to. So the inverse of a function is the relation that gets formed when the independent variable is exchanged with the dependent variable. Basically, it's the new thing that happens when you flip your x and your y's around. So if I take this original function that is in blue right here, and I take every point on there, here, let's pick a point. Here's a point. And this point right here is 0, 3. And what I do to that point is I flip its x and y value around. So I switch its x value and its y value. So that means the 0 gets moved to being the y value, and the 3 gets moved to being the x value. Well, now all of a sudden, it's right here. That's the flip. So see, what happened is it actually got flipped over or reflected over the y equals x line. Okay, it's kind of a neat thing. That's the inverse of a function. Now, sometimes the inverse of a function is also going to be a function. We have a specific notation we write our inverse of our function as. It's f negative 1 of x. Okay, that's our inverse of our function. So what I just did there is I just labeled my new relation. This was my original function, f. Let's call this guy f. Right? And then I flipped it over the y equals x line. So I reflected it. And it now becomes f negative 1 of x. And that's the inverse notation. So this is the inverse notation. Now, in this case, which by the way is right here too, the letter does depend on the letter of the function. So if this function had been named g, this would have been g negative 1 of x. Okay, so now we kind of look at that new inverse and we say, oh, is that a function or is that not a function, right? And in this case, it's still a linear function, okay? Sometimes it won't still be a function. So, for example, down here, I'll call this guy g. Why not, right? The original function is a parabola named g of x. And I take all of its points and I interchange its x and its y values, and I get this guy down here. So this guy is g negative 1 of x. That's what that one is, okay? Now, that is not a function anymore. So this inverse is just a relation, okay? Because when I flipped this entire function over the y equals x line, when I did that, I had some repeated x values. Because over here, they were just repeated y values, and they kept things a function. But over here, when I flip, now they're repeated x values. Not a function anymore. And there it is. You can think back to geometry. In geometry, you reflected things over the y equals x line. That's what inverses are. So when you've got something that's being reflected over the y equals x line, we're calling that an inverse. And so that's what this down here is saying. You know, all the things that I say when I do these notes for you, because your notes are filled in other than actual sample problems. Your actual learning part is all filled in here. So you could really read this and be in great shape, right? But that's what is happening, okay? That's what's happening, is it's the same thing as reflecting over the y equals x line, okay? So your points just flip-flop, all right? That's what's happening. Your points just flip-flop. So, hey, let's do a couple together, because why not, right? Let's see. Oh, hey, we're maroon around these parts. I'll do my original in maroon. All right. Let's graph f of x equals 2x minus 1. Well, let's go over here. Y equals, it's not going to let me change that color. Darn it. I was going to change it to maroon if I could. Oh, I can. There we go. I just need to use the keypad. I'm going to change the color. Oh, that's called brown? That's not brown, that's maroon. I'm going to leave that there. Okay. All right, so let's do that guy in maroon, right? So let's enter 2x minus 1. How about I have to be to the right first? Okay, press graph to see it. Of course, a linear function. So I can graph it right now, of course, where linear function where my y-intercept is -1 and my slope is up to right 1. So I'm going to put as many points as I can on here. It is a linear function. So I'm now going to connect using my straight edge. You know, a ruler works as a straight edge, so does the side of a graphing calculator, the side of a piece of paper, the side of a note card, all that works. I guess that does come out a little brownish on paper. I like maroon better. And now what I'm going to do, this is my f of x. Okay. Now what I'm going to do is here I'm just going to list a few of the points, right? So let's see, -2, -5. -2, -5. Okay, this one is -1, -3. 0, -1. 1, 1. 2, 3. 3, 5. Okay, that's my original. Now, I'm just going to, in the center, and because they did, the other side of the paper did this in green, I'll do this in green. I'm just going to real quick put my y equals x line here as dashes, okay? So we know what line we're going to reflect over. This is my y equals x line. This is the line we reflect over to create our inverse relation. All right? Now what I'm going to do, inverse. What color do I want my inverse to be? Let's do orange, nice and bright. What I'm going to do is I'm just going to flip these around. So -2, -5 becomes -5, -2. Can you guys see that okay? I can. I have terrible vision, so if I can, you can, right? -3, -1. Okay, so I'm flipping all these points around. Just like that. And now I'm going to graph those new points that I formed. So -5, -2. -3, -1. -1, 0. 1, 1. Oh, that sounds familiar. 3, 2. 5, 3. Now, since those points have still formed a line, and it also happens to be a function, I'm going to use my straight edge to, again, connect those. And now, what have I created? I've created my inverse. So this is f -1 of x. That's my inverse. And my inverse in this case is still a function. Okay, so the inverse, of course, f -1 of x, and it is a function. Cool. That's it. On your homework, that's what I'm going to be asking you to do. Graph the original, graph the inverse. Lots of good graphing practice. Okay. Well, I can already tell that b, the function f down here, is a parabola. All right. Oh, I know I came up with these points by having graphed the line myself here and looked at them. But on your graphing calculator, if you press second and graph, graphing calculator will give you the table of points. And so you can look at the points that would fit on this particular graph like that, right? And you can look and you can use those as your points, and that's what you flip around. All right, so I'm going to go to y equals, and I'm going to clear this guy out. Oh, I meant to clear that, not the history. There we go. They just installed my emulator today, so I'm just getting used to using it. It's exciting. I'm excited about it. All right, since some of you complain about this, the fact that this is a trash color, I'll use purple to start this time, but this is a trash color and you know it and I know it. And so let's just move forward with that. This is going to be my original, so this is going to be my f of x. It's going to be this trash color right here. Let's plug that into the graphing calculator. Why not, right? So arrow to, I think I'm going to have to go with magenta as the equivalent, right? Oh, they've got some good colors here. Look at that. Yeah, but magenta is probably the closest equivalent to the trash. There we go. All right, so we'll do that. And now this time I'll remember to arrow right first, and then I can do my x squared. Is it plus 4? It's minus 4. Got it. X squared minus 4. Press graph to see it. Of course, it's a parabola and quadratic equation. I can press second and graph to get the table of points that make it up. And what I want to do is I want to get that vertex in the middle, and I want points on each side that I can actually fit on my graph. So if I went up one more to look at negative 412, that's obviously not going to fit on a 6x6 grid. So negative 412 is not an option, but negative 35, that is an option for graphing. And then I continue from there. So then it's what, negative 2, 0? I guess I could look over here too. I really can't see it as well over here. Negative 2, 0. And negative 1 what? Negative 3. And then 0, 4, or negative 4, excuse me, should be my vertex. And then back the other direction. So 1, negative 3, did I get it right? Yeah. And 2, 0, and 3, 5. Yep, there it is. Okay, well, let's get this trash color on the graph. So negative 3, 5, and negative 2, 0, negative 1, negative 3, negative 4, excuse me, 0, negative 4, my bad. 1, negative 3, 2, 0, and 3, 5. And of course, it is parabola, so connect. Parabolic. And arrows at the end. And, you know what, I'll label over here. This guy is f of x. That's my original. Okay. All right, I am going to put my y equals x line in green. I'm going to use my other green because I want to be fair and use as many colors as possible. That's why I'm using this trash color today. Otherwise, it wouldn't get used. And that's just not fair. So let me get in this y equals x as my flip over line. And again, I'm doing that because it's your notes. You don't have to do that on the homework when you go to do all these graphs for your homework. But I want you to see what line we're reflecting over to do these inverses. So we're going to take each of these points that we've listed here and we're going to flip them all around. All right, we're going to flip them all around. So, how about light blue? This periwinkle. Let's do periwinkle, right? So negative 3, 5 becomes 5, negative 3. And negative 2, 0 becomes 0, negative 2. And we get negative 3, negative 1. And then negative 4, 0. And then negative 3, positive 1. And oh no, I no longer have a function because now I have repeated x values. So when you go to graph these, it's going to feel a little funkier just because, again, you're not graphing a function. So 5, negative 3. So 5, 1, 2, 3 down here, negative 3. 0, negative 2. 0, negative 2. Negative 3, negative 1. Negative 4, 0. Negative 3, positive 1 is now up here. 0, 2 is now up here. And 5, 3 is now up here. So see how that, and I know this is a weird thing, but I actually struggle with connecting in a parabola this direction. So I usually flip to connect my parabola well. So I'm connecting the blue or periwinkle, if you will, points. And of course, arrows at the end. Flip my paper back to how it normally was. And what I notice right away is that f negative 1 of x, my inverse function, is not a function. The inverse of my function is not itself a function, is not a function. This guy is not a function this time. Okay. You know, it's going to start to, obviously, we had this in the front too, but it's going to start to dawn on you that when you see a parabola and you're asked to flip it, your answer is not a function. Okay? That is what I'm asking you to do for homework, is when you go to do your homework, you want to graph the original, make its XY table, and then graph the inverse by flipping your X and Y points around, just like we did here. Now, I know the tables were set up for us, so you're going to have to make your own tables, but that's why we have the graphing calculator either on your Chromebook or in person. You might have your physical graphing calculator. The TI-83 works exactly the same. You just can't change the colors like this. Okay? And that's it. So, yeah. If you need any help doing this, let me know. Come to office hours. I'm cool. I love doing these. These are a lot of fun. Graphing inverses. And that is the end of chapter 1's lessons. So now we're just going to spend 2 days reviewing chapter 1 to get ready for your chapter 1 test. The reason I spend 2 days for review in chapter 1 is the function versus relation stuff is super important stuff. You really do need to know it and understand it. And so I spend 2 days with the evaluating and with the, creating these inverse graphs and compositions, because that stuff all really is very, very important for how the rest of your year looks. So 2 days reviewing, no big deal. We'll keep focusing in on it, and it gives you extra chances to come to office hours and ask me for help if you need it. All right, I'm here for you. Just email me, come to office hours, sign up, and I shall be seeing you very soon. Goodbye, math analysis. Till we meet again.